Howdy, y'all. Here we go, writing equations of quadratics. So in our first section of Unit 4, we were graphing these quadratics. And so now we're kind of working backwards. I'm not going to be giving you a graph every time, but you are going to be writing the equations, given some pieces of information, or given a graph. So just a quick reminder, there are three forms of a quadratic equation. So standard form, ax squared plus bx plus c. Vertex form, a times x minus h squared plus k. And then that root or factored form, a times x minus one root and x times the other, x minus the other root. So we need to pay very close attention to our directions because it's going to tell us what kind of format they want us to write it in. And so that's kind of going to guide us in our approach of how to write the equations. So for example 1, it says write the equation of a quadratic function in vertex form with the following features. So vertex form is basically our transformation format. So it says in part A, our vertex is at -3, 4. So I can stop right there and I can evaluate what that means to me, because if my vertex is at -3, 4, then that means I had to have shifted left 3 and up 4. And so we know how to write that in vertex form. That is the value of h and k. We also have a vertical compression of 1/3 from the parent function. So again, we also know that our vertical compression of 1/3 is that a value. So this one is really easy. So we have this function f of x, which has an a value of 1/3. It's been shifted to the left 3, and it's been shifted up 4. And that is it, guys. This is really easy. It gave us everything we wanted to know. Shift left, shift up, compression of 1/3. In the second one, it tells us that it has a vertex of 4, -1. So again, it tells us it's been shifted right 4, down 1. This time it tells us that the value at 3 is 6. So it says f of 3 equals 6. So remember, f of 3 is saying when x is 3, the function value has a value of 6. So I am going to use that information to solve for my a value, because that's the only thing I don't have for vertex form. I have my value of h, I have my value of k, I just don't have the value of a. So I'm going to use that ordered pair 3, 6 to help me solve for that. So using the vertex here, this would be f of x equals a times x minus 4 squared minus 1. If I use this 3, 6, that means I could plug in 6 for y, a I don't know, 3 is x, and then I can evaluate and solve for a. So this would be 6 equals a times 3 minus 4 is -1, 1 squared is 1, minus 1. So that means 7 equals a. And so if I write that now, come on. If I use that value of a and I use my value of h and k, then my function is going to be f of x equals 7 times x minus 4 squared minus 1. And that is my quadratic equation in vertex form. Okay, so you have to use what you have, plug it into the format that you want your answer to be in, and solve for anything that you don't have. Okay, so let's try it again. This time it says I have a vertex at 6, -1 and a root of 4. So let's take a step back and think about what that means. The vertex is easy, right? That's f of x equals a times x minus 6 squared minus 1. So I've used my vertex. I'm done. But now I need to incorporate this root of 4, and my goal is to solve for our value of a. Well, a root of 4 is an x-intercept, so that is a point at 4, 0. So I can do the same thing in part B. I can plug in 0 for y and 4 for x and solve for my value of a. So this is going to be 1 equals 4 minus 6 is -2. -2 squared is 4, so this is 4a. So that means a has a value of 1/4. So putting that all together, 1/4 times x minus 6 squared minus 1. Going on to the second one, we're given the axis of symmetry is x equals 2. The range is negative infinity to negative 4, and our y-intercept is negative 12. So we don't know a whole lot of information, but we actually know more than we think we do. So axis of symmetry is x equal to. That is the value of our h. That is the x coordinate of our vertex. So we actually know our h value is 2. So this is going to be f of x equals a times x minus 2 squared. Our k value, I'm looking at that range. The range is from negative infinity all the way to negative 4. So that means my vertex has a k value of negative 4. Because the range is from negative infinity to negative 4, I know that my a value needs to come out to be negative because it's opening downward. So that's something to keep in the back of my brain for later on. So I've used my axis of symmetry and I've used my range. Now let's use this y-intercept of negative 12. A y-intercept of negative 12 is the coordinate 0, negative 12. So if I use that and plug it in to solve for a, negative 12 equals a times 0 minus 2 squared minus 4. So this is going to give me negative 8 equals 4a. So a is equal to negative 2. Which makes sense because, like I said, it has to have been reflected over the x-axis. And so getting an a of a negative value is good news. So that means I have f of x equals negative 2 times x minus 2 squared minus 4. And there we have it. Okay, so all of those were taking pieces of information and putting it into vertex form. Example 2, same thing, but now we want it in standard form. So remember that's ax squared plus bx plus c. So let's take a look at what they give us here. In the first example, it says they give us zeros of negative 7 and 5 and an a value of 2. Well, if I know my zeros and I know my a value, I could plug all of this into root form and then just multiply those two binomials together and distribute to get it in standard form. So let's write it out. An a value of 2, a 0 of negative 7, so minus a negative 7 is plus 7, and a positive 5. So I can multiply or FOIL, multiplying your binomials or foiling or box method, whatever you use. This is going to give you x squared minus 5x plus 7x minus 35, which means I now have 2 times x squared plus 2x minus 35. Distributing that 2, I get y equals 2x squared plus 4x minus 70. And this is now in standard form. An a value of 2, a b value of 4, and a c value of negative 70. Let's try it again. In the second one, they give us zeros of 2 and negative 5. So again, I'm going to kind of use that root form and multiply out. But this time, they don't give me the a value. They tell me that f of 3 is equal to 4. So remember, that's 3, 4. So let's plug in what we know. Y is equal to a times x minus 2 times x plus 5. And then let's plug in 4 for y and 3 for x and evaluate. And so now I have 4 equals a times 1 times 8. So a times 1 is 8. Dividing by 8 gives me 4 over 8, which is 1/2. Oops. So that is the value of my a. So now I know I have a value of a. So I can do y equals 1/2 times x minus 2, x plus 5, multiply. Combine like terms and distribute. So 5x minus 2x would be 3x. 3 times 1/2 would be 3/2. And then 1/2 times negative 10 is negative 5. And so now I have it in standard form. An a value of 1/2, a b value of 3/2, and a c value of negative 5. So we kind of had to do double the work for this one because I didn't know the a value to begin with. So I had to use what I had to find the a value. Then I had to multiply everything out and distribute to get in standard form. And then one more example to get in, a couple more, sorry. So example C, it says the only x-intercept is 2, and it has a y-intercept of negative 12. So if our only x-intercept is negative 2, is 2, then that means I have y equals a times x minus 2 squared. When I only have one x-intercept, it is the vertex, okay? So that is my h value. A y-intercept of negative 12 is obviously 0, negative 12, and so now I can use that to solve for a. So this is going to be negative 12 equals 4a. So a is equal to negative 3, which makes sense because my y-intercept is negative and my x-intercept is 2. So it makes sense that this should be opening downward. And so putting it all together, now I have y equals negative 3 times x minus 2 squared. I can't leave it like this, even though this is an answer. It's just not in the format that I wanted it. I want it in standard form. So when I square x minus 2, that is not x squared minus 4, guys. X minus 2 squared is not x squared minus 4. You got to be careful. This is x minus 2 times x minus 2, which if you FOIL it out, would give you x squared minus 2x plus 4, which is actually x squared minus 4x plus 4, okay? Be careful there. So this goes here, and all I need to do now is distribute that negative 3. So negative 3x squared plus 12x minus 12, and there you have it, okay? Going on to the second page. This one's going to be a little bit more challenging, so but it's just a review of something that we've already done this year, which is systems. So what they're giving us is a parabola, a quadratic that contains 3 points. Now, we don't know out of these 3 points if one of them is a vertex or anything like that, so we cannot assume anything. We know we want our answer in standard form. So what we're going to do is we're going to create 3 equations with these 3 points, creating a 3 by 3 system. So using the first point, 0, 1, y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. Okay, let's go to the second one. Y equals ax squared plus bx plus c. Third one, y equals ax squared plus bx plus c. This is our 3 by 3 system, okay? So we are going to solve this. Luckily, in that first equation, 0 squared is 0, 0 times anything is 0. So we literally have 1 equals 0 plus c. So that means 1 equals c. So I already know my c value. So what I can do now is plug that in to the second and the third equation and kind of simplify what I have. The second equation is 10 equals 9 squared is 81 times a plus 9b plus c, which we know is 1. Our third equation is 25 equals negative 6 squared is 36. So this is 36a minus 6b plus c, which is 1. And so now we have these 2 equations. And so what I can do is I can simplify a little bit further. So over here, I subtract the 1. I get 9 equals 81a plus 9b. Everything is divisible by 9, so 1 equals 9a plus b. Over here, 24 equals 36a minus 6b. Over here, everything's divisible by 6, so this is 4 equals 6a minus b. And so what I'm going to do is I'm going to solve one of these for a variable and do a substitution. I'm going to go ahead and do 1 minus 9a equals b, and so I will take that and substitute it in for my b over here. So this is going to be 4 equals 6a minus 1 minus 9a. Distributing the negative, combining like terms and solving, I get a to be negative 2. Okay, you could add the 1, combine the 6a and the 9a, divide, you get a to be negative 2. So, oh no, I'm sorry. Oops, sorry. You get a to be 1/3, because you have 5 and 15. 5 divided by 15 is 1/3. Okay, so my a value is 1/3. So I can plug that back in over here. 1 minus 9 times 1/3 equals b. Well, 9 times 1/3 is 3. 1 minus 3 is a negative 2. So that means b is equal to negative 2. So I have all my coefficients. A is 1/3, B is negative 2, C is 1. But that's not what I want. I'm not done yet. I have to take all of that and plug it into standard form. So I'm going to make this smaller. So what do I want? I want f of x equals a x squared plus bx plus c. And there it is in standard form. That one was long. I told you though. But it's not hard. It's just a review of 3x3 systems. Okay. In this next example, I need you to change some of these values. So I need you to change that your axis of symmetry is actually x equals 2. I need you to change that second point to be 5, 2. And then that third point to be negative 4, 20. Okay, it just makes our life a whole lot easier. So here's what I need to do. I need to evaluate the information given to me. If I know my axis of symmetry is x equals 2, then I know my vertex is at 2 comma something. And that is my h value and my k value, okay? Now I also have 2 points on this quadratic. Again, I don't know if they're, I don't know anything about it, just that they're on the quadratic. So I'm going to do another system. But this time, because I know my vertex pretty much is 2 comma something, I'm going to use these points and the value of h. So I'm going to plug it into vertex form, which we know is y equals a times x minus h squared plus k. So let's use this first 0.52. Y equals a times x minus h squared plus k. X, y, and then h up here. Okay, that's the first one. The second point would be y equals a times x minus h squared plus k. And so now I have a 2x2 system that I'm going to use to solve for the value of a and the value of k. Well, first what I'm going to do is I'm going to simplify. So I have 2 equals 5 minus 2 is 3. 3 squared is 9. And then 20 equals negative 4 minus 2 is negative 6. Negative 6 squared is 36a plus k. And so then I can, I'm going to do another substitution here. So I'm going to solve this first one for k. So k is going to be 2 minus 9a. I'm going to plug that in. So this would be 20 equals 36a plus 2 minus 9a. So this is going to give me 18 equaling 27a. So a is equal to 2/3. Okay, I can plug that in here and get k equals 2 minus 9 times 2/3. 9 times 2/3 is 6. So 2 minus 6 is negative 4. So now I know the value of k, I know the value of h, and I know my value of a. So that's great, but I don't want it in vertex form. I want it in standard form. So I'm going to take all this, make it a little bit small. Come on. Okay. So what I'm going to do now is I'm going to first write it in that vertex form. So y equals a times x minus h squared plus k. All right. So what I'm going to do now is I'm going to expand x minus 2 squared. Now I need to distribute. And then now I need to combine those like terms at the end. A positive 8/3 minus 4. 4 would be like 12 over 3. So 8 minus 12 is a negative 4. And so now finally it's in standard form. Okay, moving on. Now I need to write the equation of g of x based on the listed transformations from f of x. So in the first couple problems, my f of x is just the parent function. So that's wonderful. I'm just applying transformations. So in the first one, it says f of x is equal to x squared. I need to shift it left 3, vertically compress by a factor of 2/3, followed by a vertical shift up 1. So left 3 means it's now going to be x plus 3 squared. Vertically compressed means I multiply that by 2/3, and then I follow by a shift up 1 unit. Everything is in the correct order that I want it to be in, and so this is my new function. The second example, again, we're starting with just a parent function of x squared. Horizontally compressed by a factor of 3/4. Remember, for horizontal compressions, I'm really seeing a number bigger than 1 because I'm dividing by that number. So really it's 4/3 x squared. Shift down 3, followed by a reflection over the x-axis. Okay. I'm going to leave it like this. Technically, you could go negative 4/3 x squared plus 3, because if I go down 3 and then reflect over the x-axis, I'm really going up 3. So these are the same thing. If I do that, there we go. So really this would kind of be your final answer. Okay. So the next two, I am not starting from the parent function, so you got to be careful here. The first, or part C, says I have x minus 2 squared. So I've taken my parent function and I've already shifted it to the right 2 units. That's where I see that minus 2 on the inside. So the first thing I want to do is I want to vertically stretch by a factor of 3. So that just means I have 3 times x minus 2 squared. Nothing is changed. That's totally fine. Then it says I want to shift left 7. Well, if I'm already right 2 and I go left 7, that ends me up at just being left 5. And so then I can just do that. Then the last one. The last one is not in vertex form. We have x squared minus 5x. So it looks like standard form. So what we want to do is we want to shift it 3 units to the right and 2 units up, followed by a reflection over the y-axis. So what I'm going to do is I'm going to write the transformations in that just function notation. I'm going to ignore what I'm starting with from the beginning. So if I go 3 units right and 2 units up, that would be x minus 3 squared plus 2. But then I follow by a reflection over the y-axis. That's on the inside. So that would be a negative x minus 3 squared plus 2, which is really just negative x plus 3 squared plus 2. So this is the transformations that I need to do. Now I need to apply it to this function, okay? So everywhere I see my x, I need to replace it with what's inside of the parentheses, right? So I have x squared. So this is going to be negative x plus 3 squared minus 5x, which is negative x plus 3. And then I also have a plus 2 at the very end. So plus 2 at the very end. And so now what I can do is I can expand this and simplify this. So this is going to give me positive x squared minus 6x plus 9 minus, well, really negative 5 times negative x is positive 5x. Negative 5 times a positive 3 would be negative 15, and then plus 2. And so now I can combine like terms. So I have x squared minus x, and then I have a plus 9, a minus 15, and a plus 2. So 9 minus 15 plus 2 is going to give me a negative 4. And so now this is my g of x. And then lastly, I'm giving you a graph and I say write the equation in standard or vertex form. The first one we are omitting because we do not know how to write the equation of a left opening or right opening quadratic just yet. We're going to learn that later on in the unit. So we only have 2 graphs to look at. So the second graph, I want to just start picking out information. I first noticed that it's opening down, so it had to have been reflected over the x-axis. I also see exactly where my vertex is. It is at positive 2, negative 1. So 2, negative 1. And so what I'm going to do is I'm going to start writing this in vertex form because I know, like I said, that it's opening down. I don't know what my a value is just yet, but I know it's going to look like x minus 2 squared minus 1 because of where the vertex is. Now I also have these really good points here and here. So this is at 5, 1, 2, 3. This is at 5, negative 4. And this is at negative 1, negative 4. And so from my vertex, I went right 1, 2, 3, down 1, 2, 3. So if I went right 3, down 3, originally it's supposed to be right 3, up 9, but I know I've reflected, so it really would have been right 3, down 9, but if I'm only going down 3, then that means I did 1/3 of that. So my a value must be a negative 1/3. And of course, you could plug in some of those x and y coordinates and solve for a, and you will get a negative 1/3. Okay, now for this equation, or for this graph, excuse me, I don't want to guess where that vertex is. So I don't want to say, oh, the vertex is at something negative 9. But what I do know for certain is that we have some roots at 0 and 3. So if I know my roots, I'm going to start writing this in root format. Even though I know I can't leave it in root format, I can at least start it. So if my roots are 0 and 3, then that means I have y equals a times x minus 0, which is just x, and x minus 3. Now I can use some other points on this graph to help me out. I see a really good point right here. That point is at 1, negative 8. So this is at 1, negative 8. So if I use that for y and x, I can solve for a. Okay, it makes sense that a is positive because my graph is opening up. So this means that I have y equals a times x minus 3. I can't leave my answer like this because that's in root form and I only want standard or vertex. But what I can do is multiply this out. 4x times x minus 3 is 4x squared minus 12x. And that is now in standard form. I just don't have a c value.